Is Bazzite truly a gaming distro? Let us find out. We go to the official website and download the desktop version for testing. We select NVIDIA legacy drivers and the KDE Plasma desktop. We wait for the image to download and then write it to a USB drive. We boot the image. Bazzite is a distro based on Fedora and designed to run Steam. The first release of this system was in 2023. Upon booting, the welcome message appears and we click Install Bazzite. We select the language and the required keyboard layout. In my case, Latin American, we adjust the dates. We select the disk and installation method. I choose to use the entire disk. In Accounts, we enter the full name, username, password and confirmation the same for the admin account. Then click Next. We check the box and click Erase Data and install. The installation on a legacy computer takes around 20 to 30 minutes. Bazzite is immutable with atomic updates. It uses Brew, Flatpak, AppImage, and the slower RPM OS3 package manager. The system boots for the first time with an average boot time. Then we enter the password and access the selected desktop. Inspecting the menu, we see a link to Steam. Ready to use. As gamers know, Steam is a well-known video game platform. We continue the menu review and see it includes default desktop environment packages plus those related to gaming tools. We open the terminal and increase the font size for better visibility. We can see Bazzite NVIDIA is stable just like the boot. We try updating the system with DNF to stay current. However, as mentioned, Bazzite is immutable, so DNF does not work here. We can use Ujust or Brew to install packages. We prefer Brew for automation. We install FastFetch and then sysbench tools. Sysbench is a programmable multi-threaded benchmarking tool based on Luajit IT. It is used to perform performance tests. We run FastFetch to view system info. We get the kernel version, which is very recent, although not the latest available. We can see idle memory, which is very high, although some distros do this for responsiveness. MB per package is also high. We use commands to verify the information, which is correct. We see Bazzite is based on Fedora 43 and uses NVIDIA drivers. We verify memory and disk. We also measure boot time, which is average compared to other available Linux distributions. Now, we run sysbench for CPU on a single thread, calculating primes, which measures the single-core performance levels. In this single-core test, solid performance was obtained with good stability in calculations and consistent execution times. Then, to measure multi-thread power, we run sysbench CPU with parallel load, analyzing scaling efficiency on 5 threads. In the multi-thread test, average scaling was observed using 5 threads with a moderate increase in overall performance. When analyzing the scheduler, we run sysbench CPU, evaluating latency when multiple threads compete for system resources. In the scheduler test, control latency was observed, maintaining stability under concurrent load and execution scenarios. Now we start a sync test where we run sysbench CPU measuring Mutex log performance under high contention scenarios. In the Mutex test, the system showed moderate log handling, with low contention and average performance in parallel tasks. Then we run sysbench for memory in read mode, quantifying bandwidth and access speed to data stored in system RAM. In memory read, good bandwidth was achieved with fast data access and stable performance during continuous operations. To measure write throughput, we run sysbench memory, analyzing the data transfer rate directed to system RAM storage. In memory writing, an efficient transfer rate was achieved, reflecting good data flow management to system memory. Before the disk test, we ran sysbench storage, preparing a 1 GB file environment for input and output benchmarks. For the final benchmark, we ran sysbench disk input and output, validating random read and write speeds under test conditions. In the final disk test, balanced performance in random read and write was not achieved, showing low real workload values. Then we ran the top command to check memory used by a Firefox window, then open a second tab with a video. We continue opening a third and fourth tab, observing the increase in memory usage. Average usage per tab was moderate. First, we try homebrew management using brew install GL Mark II, but the package is not available in this environment. As an alternative, we run rpm-ostree install GL Mark II, finding the package in repos, though it downloads many dependencies. However, rpm-ostree is extremely slow due to its layer design and also requires a system reboot to apply changes. Despite the slow install with rpm-ostree, NVIDIA drivers are installed and ready to run using the NVIDIA SMI utility. Now we run GL Mark II for CPU and Intel integrated, analyzing shader performance and MISA driver efficiency in 3D. We evaluate Intel GPU capacity to process textures and geometry, measuring FPS under load, achieving excellent results. Then we run GL Mark II for CPU and GPU using NVIDIA offload via environment variables to activate the dedicated GPU. We measure NVIDIA raw performance by evaluating frame rates and rendering power under high load with great results. We have finished the system evaluation. Below we present a summary of the results obtained during the tests. In conclusion, Bazzite 43 shows very good overall performance. It has good integration and strong NVIDIA gaming support. However, it has areas to improve: memory usage, concurrency scheduling, and especially disk read and write performance. That is all for this video. If you liked it, subscribe, leave a like, and enable notifications. See you in the next video.